Hi students, today I have a popular request to discuss with you, and that is integration. I wish to solve this section in a different frequency against the paralyzing views on integrand. And lest I forget, let me bless you for blessing me with your subscriptions. I highly appreciate you, and I think I need to pinpoint that. Look students, integration is a pyramid where its base is a basic integrals and its height is techniques of integrals. By that I mean, today we are going to be looking at one of the techniques called trigonometric substitutions. Very easy. Check. You have three things to really master, and that is the expression in the integrand and the correct substitution. And what? And the correct identity. You have a bunch of identities. So now you need to identify this expression, the square root of a particular number, and that number has to be a perfect squared. That is a squared minus x squared. So if you have that situation, you are going to let your x to be a sine theta, where theta is defined in between minus pi over 2 and pi over 2 inclusive. That is in the first quadrant and the fourth quadrant. All right. Remember, this is minus 90 and negative 90 in degrees. And then now we are going to be using this particular identity, which is called the square identity, which is cos squared theta is equals to 1 minus a sine square of theta against the half angle identities. Now, we are going to also have this expression just right here. That is the square root of a number. That number has to be a perfect square. In fact, let me clarify this thing of a perfect square. We are talking about 1, 4, 9, and then 16, and then 25, 36, 49, 64, 81, 100, 121, and so forth. Those numbers are perfect square on the premise of the fact that they can be written as 1 squared, this is going to be 2 squared, and this is going to be 3 squared, this is going to be 4 squared, and so forth. You can see that you're going to get a 5 squared, 6 squared, and your 7 squared as perfect squared. So if you can have that, so we are going to have this type of expression. All right. Now, the second one is that you're going to have the situation, but this time around, it's positive in between. So we are going to have a different substitution to say we are going to get x is equals to a multiplied by the tangent of what? Of theta. But remember that theta is the angle. So we are saying this theta it should be defined in between the first quadrant and the fourth. But this time around, these angles are exclusive on the premise of the fact that tangent is not defined at those angles. So just right there. All right. And that's why they are exclusive. And we are going to be using that one, which is Pythagorean identity. That is tan squared plus 1 is equals to the second of theta squared there. All right. Now, the last one, you're going to have a vice versa of the first one. That is x squared minus a squared. And then now you're going to be having this particular substitution. And of course, your theta, it has to be in the first quadrant or the third quadrant. Remember, it's from 0 to pi over 2. That means from 0 to 90. So that is primarily your acute angle in the first quadrant, or you can use that one in the third quadrant where pi is included and 270 is excluded. All right. So we are going to be using that particular identity in there. I have 3 examples to discuss with you here. And the first one is the integral of the square root of 9 minus x squared over x squared dx. And then the last one is the integral of 1 over x squared multiplied by the square root of x squared plus 4 dx. And then the last one is primarily the integral of x over 3 minus 2x minus x squared. So I'm going to do them in parts. I'm going to do the first one as part number 1 because, you know, these type of problems, they really take time. So I want to do the first one as part 1, and then you must watch part 2 as well because I'm going to be doing this one, and this will be your part 3. And then it will be done. You can do anything in your exams. Let's check. The first one, we are given the integral of root of 9 minus x squared over x squared multiplied by dx. So I'm going to write it here that I'm going to get the integral of 9 minus x squared divided by x squared dx. Pay attention. I'm going to rewrite this integral in such a way that I see what is my a. So you're going to get a square root of 9. What is 9? 9 is a perfect squared. So it's similar to saying that this is 3 to the power 2. And then you have a minus of x squared divided by your x squared dx. I wanted to see something. Once you can have this particular expression here, that is a squared minus x squared. That is the first expression. So you are going to say, let your x be a sine theta. So your a in this case is this number called 3, just right here. So I'm going to say, well, I'm going to say let x be a sine theta, but my a is 3. So this is going to be 3 sine of theta. I must say where my theta, it has to be in between negative pi over 2 and pi over 2. You will see this when I have to draw the triangle in that it's going to be in the first quadrant or the fourth quadrant. Now check. I'm going to find dx just right here because I need that in my integrand. So let me find dx. So dx, it means I'm going to be deriving this situation. If I differentiate 3 sine theta, I'm going to get a 3 cos of theta multiplied by d theta. But I also need x squared. So let's check. What is x squared? X squared, it means I'm going to square this value here because that is x. So I'm going to get a 3 and then a sine of theta. I have to square this situation. Let's check. What do you get? You get a 9 and then you get a sine squared of theta, just right there. Let me bring it this side so that everything is on the same line. So now I just need to integrate. Let's check. How do I do that? I say, well, this is the integral of the square root of 3 squared. So that is more like 9 minus x squared. X squared is 9. So this is 9. Let me really delay that. So this is 9 sine squared of theta. I'm just going to put my square root now. I divide this by x squared, which is 9, and then a sine squared of theta. And then what is dx? Dx, I got it just right here, and that is 3 sine of theta, and then d theta. I want you guys to see something. From here, it's a basic integral. That is really going to be equals to the integral of that square root. So you can factor out your 9 because it's common. 9 is common just right here. If I take it out, I'm going to have a 1 minus a sine squared of theta. I close that. I divide this by 9 sine of squared of theta just right there. Oh, well, my dx is basically this one. So I need to put a cos here. I need to be very careful. This is going to be cos of theta for dx. Remember, I have to plug that dx. So dx, I got this one. So which is really that one. Sorry about that that mistake. Well, let's check. We have a 3 cos of theta d theta. Now, I wanted to identify something just right here. This is going to be the integral. If you look at inside here, you have a square identity. So let's check. That is equals to a cos squared. That is a cos squared. Let's go and plug that. So we are going to say, well, this is the square root of, we still have our 9, but this one is a square identity, and it's going to be a cos squared of theta. Be very careful there. I have to divide this situation by 9 and then a sine squared of theta multiplied by 3 cos of theta d theta. Check now. You are going to then now say that The square root of 9 cos squared, you are primarily going to get a 3 there. So this is going to be 3 cos of theta divided by, this is 9, and then a sine of square of theta multiplied by 3 sine of theta d theta. Pay attention now. This is going to be the integral of, if you multiply this one and this one, I don't know why I keep writing sine instead of cos. So that is my blunder. Forgive me for that. That is a cos of theta. If you multiply them, if you multiply this one and this one, they are going to give you something like 9 and then a cos squared of theta. You have to divide this by 9 and then a sine of square of theta d theta. Now, I wanted to say something. If you simplify it nicely, the 9 and the 9 are going to undo each other. So you're going to be left with the integral of what? Cos squared over sine squared. It's primarily like a cot squared. So this is a cot squared of theta d theta. So now you want to integrate a cot squared of theta. But you and me know that if you have a sine squared of theta plus cos squared of theta is equals to 1 from high school, if you are to divide both sides by sine squared, you're going to get a 1 plus, if you divide by sine squared, this is going to be a cot squared of theta is equals to 1. I mean, 1 over sine squared of theta is a cosec. This is a cosec of theta. Therefore, cot squared of theta is equals to, this is going to be equals to a cosec squared of theta minus 1. All right. So this implies to us that this integral here, it's going to be equated to cot is the same as cosec squared of theta minus 1 and then d theta. Now it's a matter of algebra here. This is going to be the integral of cosec square of theta minus, but I have to put d theta here, minus the integral of 1 d theta. This tells me that if I integrate cosec square of theta, I'm going to get a negative cot. It's a negative cot situation of theta. If I integrate 1 with respect to theta, it's going to be theta, but there's a negative in between. So I'm going to write a negative theta. Remember that this is integral, so you must write plus c. Now, I want you guys to pay attention. This answer of ours is in terms of theta, but our problem was given in terms of x. This was given in terms of x. So you need to make sure that your answer is in terms of x. So you are going to play just right here to say, well, let's take this particular expression, equation. It's an equation. So let me paste it here and really play with that. Check. I'm now going to divide both sides by 3. So this means that I'm going to have a sine of theta is equals to x over 3. Let's go back to high school. What is sine? What is the trig ratio of sine? That is the opposite over hypotenuse. So if you were to draw that, but remember that you said that your theta has to be, where is it? Has to be in the first quadrant or the second quadrant. So now you're going to say to yourself, now that you have this situation, which is a positive one, you're going to say, where is theta, where is sine positive? So sine is positive in the first quadrant and the second quadrant, but your theta has to be either in the first or fourth. Hence, I'm going to draw this one in the first quadrant. So let's do that. I'm just going to have this in the first quadrant because my theta, it has to be in the first or fourth. So, but because sine is positive, I'm going to draw that in the first quadrant. Well, I'm just going to do this for you in the first quadrant. So what is the opposite? The opposite of this one is x. I hope this you know, hey? So this is x. What is the hypotenuse? The hypotenuse is 3. So you just need to get the adjacent one, which is by Pythagoras theorem, I would like to believe. If you say, remember that this is by Pythagoras, you can do that. It's 90 degrees just right here. So you can do this by Pythagoras theorem from your high school maths, and that is going to give you the square root of, you square the hypotenuse minus the opposite side to get the adjacent one. It's going to be 9 minus x squared. That should really be easy. You use Pythagoras theorem to find that adjacent side. Now, I want you guys to follow with me now. You got the integral. You got this integral. This was your integral. Let me copy it. I'm just going to paste it here. So this integral here, you gave me the answer that is equals to this one. Let me copy it and paste it here, just right here. This is the answer for the integral. So I want you guys to see something. Now, you are looking for cot theta. Remember that you have your theta just somewhere there in the first quadrant. It's basically acute angle. So you have a cot theta. What is a cot? Cot is primarily the adjacent over the opposite, because the tangent is it's vice versa. It's the opposite of adjacent. So the cot is the reciprocal of that, But you need to also show that from here, you also need your theta. First, let's get this one right. So you're going to get a negative situation. Cot, you are going to look at your diagram, is the adjacent over opposite. So what is the adjacent? Is the one that you found with Pythagoras theorem. So you're going to get the square root of a 9 minus x squared divided by x. So this one is the trig ratio of cot. You now say minus theta. How can you find theta? Remember, you have this situation here. How do you find theta? You can apply what you have learned in high school as well again here to say that if I want to find theta, this is going to be the inverse of sine, like the arc of sine of what? Of x over 3. If you want to solve for theta there, it's going to be the arc of x over 3. I think that should suffice, So this in general, you're going to get for theta, which is this one. So that is the inverse of that, and that is x over 3. Remember, you still have your plus c just right there. So this will then give you the answer of the integral of 9 minus x squared divided by x squared dx.